Good morning, everybody. I'd like to first thank you for all spending some time with John and I this morning while I discuss how to utilize smartSECTION and FrameBuilder to better interpret and display your fault geometries in the project areas. Now, as most of you know, included in your Discovery GeoGraphix package is the smartSECTION module. This can be accessed by clicking this icon. In addition, you can purchase FrameBuilder, which gives the user a live interactive map view interface of the smartSECTION interpretations that are occurring. Now, smartSECTION all by itself is a very powerful 3D geologic modeling tool that can be very useful when interpreting the stratal geometries in your area. I like to always remind everybody that it's not just a tool to make cross-sections, and today we will see why that is true. Now, while one of its great strengths lies in its ability to pick and display formation tops and conformities and generate conformable surfaces, a topic for a future webinar, it has a very sophisticated set of structural analysis tools that can help you more quickly and accurately identify your structural geometries within the scope of a true stratigraphic framework. FrameBuilder enables us to manipulate the 3D model created in smartSECTION and display real-time maps of these interpretations. This ability enables us to better display and interpret our fault geometries as we are making our interpretations. The focus of today's webinar is going to be how to work with faults in smartSECTION and in the FrameBuilder map view. The specific goals that we're going to cover are we're going to review how faults are stored and managed in the GeoGraphix Discovery suite of tools, how to pick and display faults in smartSECTION using the fault offset and fault networking tools. We're going to learn how to display, edit, and interpret faults in FrameBuilder's map view, how to gap faults and restore original stratigraphic geometries within the cross-section, and finally, I'm going to show you a little bit about how to export fault data from the smartSECTION world and FrameBuilder world back into your GeoAtlas maps and use that data to refine your overall structural interpretation. As I mentioned, the smartSECTION FrameBuilder combination contains some very useful tools for structural analysis. The ability of FrameBuilder to display the fault picks in map view in real time is very critical because it enables you to instantly visualize the fault geometries, giving more guidance to your interpretation. While GeoAtlas has historically enabled us to make and display maps on formation picks, FrameBuilder, in contrast, enables us to have the real-time visualization of each fault plane and its intersection as we correlate the cross-sections. In addition, since smartSECTION is a 3D geological model of our study area, you can now clearly see fault geometries that occur between the wells, not just at the wellbore site. This ability has led directly to the development of more interwell prospects and the better understanding of the geometry of the entire section throughout the modeled area, and not just what you can see at individual well sites. This has been very useful for users who use fault placement when geosteering unconventional plays and coming up with other prospects. In addition, we now have the ability to gap wells and show the vertical separation values associated with each fault pick and use this information to reconstruct the pre-faulted stratal geometries which help us and assist us in the correlation and interpretation of these faulted regions. We can even actually pick missing tops and create surfaces on formation tops that have been faulted out. Now today I'm going to use a small data set to illustrate our work with faults in the onshore Gulf of Mexico. Here there are various deep gas trends that are intersected by a series of large growth faults. Interpreting the faults in this area is essential in understanding the original geometry of the regional sand trends, the basin configurations, and potential migration pathways within a stratigraphic framework. Before I start, I'd like to discuss a little bit about how fault data originates and is managed in well-based as well as smartSECTION. After all, the well-based data manager is where the majority of smartSECTION data is stored and viewed. Now, what are the sources of fault data? First of all, fault data such as names and pics can be imported into well-based via digital files such as spreadsheets and DEFCONs. In addition, this kind of fault data can be entered into well-based's fault tab manually, and fault data can be created and picked in both the smartSECTION and XSECTION cross-sections. Finally, fault names can be manually entered into the fault manager. No matter how faults are created, they are all ultimately stored in the fault manager. You can access the fault manager by going to Well-Based, Tools, Fault Manager. Here's an example of a fault manager dialog box where we have a list of various faults in a project, and it shows the internal fault ID, a fault name, and a fault type. The fault ID really is the key field because it relates to the name of the faults that are created and used in all your cross-section views and in your well-based tab, and it will reflect any new fault names that are made in smartSECTION. The fault type here is a field that describes what kind of fault it is, for example, a reverse or normal fault. However, this field is purely informational. The type of the fault does not affect how it's modeled in smartSECTION. Whether a fault is normal or reverse is determined made by the pics of the geoscientist and how those pics affect the local 3D structural geometry of that area. Now, each time a new fault is created in smartSECTION, that fault name will automatically be stored here in Fault Manager as a unique fault ID. In order to delete a fault name from the database, one must come here to Fault Manager to delete the fault. However, individual pics that are related to a particular fault name can be deleted directly in the cross-section or in smartSECTION's map view. Now, all faults that are made directly on each well in the smartSECTION cross-sections are automatically stored in the Faults tab here in Well-Base. There are several columns of information that are in this tab, including the vertical separation, source, observation numbers, fault IDs, etc. The vertical separation value calculated here in smartSECTION will be automatically placed here. Now, all fault picks that are actually picked and created in the interwell of the smartSECTION cross-sections are not stored in any visible well-based table. They are stored in the database, however, and they can be queried in Query Builder. By clicking on the smartSECTION icon in Query Builder, you can access the interwell fault cuts fields and query on these various options. Now, at this point in time, John, have any questions come in regarding to faults themselves in well-base?
No questions so far, Beverly.
All right, great. Okay. Now, when working with faults in smartSECTION, it's a very interpretive process. Unlike most cross-section software, where one can just casually enter an estimated fault position or even a fake fault to illustrate a point, smartSECTION's geologic model will not model faults accurately that are not geometrically reasonable. In other words, unless fault picks are reasonable with respect to all the data entered into the model, the fault will not display properly. Therefore, it's very important to have some knowledge of your area, a plan for picking faults, and all surfaces that you're using must be entered into the Strat Column Manager in correct stratigraphic order. If you do not do this, you will not get good results. I think as I work through this exercise and explain how the model functions, this point will be better illustrated. Now, before we go to the live demo, I want to review a slide that illustrates how smartSECTION models fault data. Now, what happens initially in the smartSECTION 3D model is it creates a series of surfaces based on the geologist's information and picks at each well site. As the surfaces are created, one can observe some kinks in those surfaces, indicating the presence of a potential offset or faulting. The geologist can then insert the location of the fault picks, and the smartSECTION model will independently create a structural surface on each side of the fault. The fault plane, based on the geologist's picks, is contoured and can be displayed immediately in map view. Once the fault offset is determined, then basically the independent surfaces on either side of the fault plane will be truncated against that fault. If the area of interest, and this is a very important point, has a lot of control points, the smartSECTION model will handle the offset on its own and it will look very reasonable. However, if control data is sparse, the geologist can manually enter a vertical separation value himself or herself, and the model will honor it and offset the surfaces accordingly. Okay, so let's go ahead and go to the North Thompson Gulf Coast area, and I'm going to show you how the faults are picked and displayed. I am not going to review how cross-sections are built today. For those of you who missed my first webinar on this topic, you can always go out to our website and review the webinar entitled Demystifying smartSECTION. Now, because the explanation of fault workflows can get complicated pretty quickly, I chose to use an extremely simple geologic scenario here. I'm just going to go ahead and turn on one surface in this area. I want us to focus on the workflow and not on interesting geology today. Sorry to disappoint some of you. This project consists of a series of stacked deltaic and shallow marine to deep water sands intersected by a large down to the south growth fault. This is a well-to-well cross-section shown here in magenta in map view. Now, in order to first pick a fault, you must first have an assigned fault name or a generic fault name. The fault name can be an existing fault name out there in your GeoGraphix project, or we can create a brand new fault name. To turn on an existing fault name, all we do is go to the GeoSurface Model Properties tool, a very important tool here in smartSECTION. When you open that up, you can go to your Faults tab, and there will be a list of all your existing faults in your data set. In order to turn on a fault, all you have to do is toggle it on. In this particular tab, we also have the option of saying how far away from known control points do we want to extend our fault. So if you want to have a lot of control on that fault and not extend it out very much, you can put a very low extension factor like 0.1 or even 0 if you don't want it to extend at all. Or you can bump it up higher if you wish it to extend throughout your region. Now, in addition, you can turn on your Surfaces tab. Here in our Surfaces tab, there's all the picks that you've made on your wells that have been created and turned into surfaces. So I've got several surfaces turned on in this particular case. When I go ahead and say OK, and I just want to turn something off while we're here, I'm not going to click anything. I'm just going to say cancel, and I'm going to turn that offset tool on because I'm going to get there in a minute. So we've actually turned on our faults. They're going to show up not only here on the left side in our cross-section view, but the faults are also going to show up and be present in our map view. I'm going to turn our correlations down here. They're going to be located down here underneath faults in your FrameBuilder map view. Now I'm going to go ahead and pick a named fault, but just a comment about the generic fault possibilities here. Their purpose is to basically mark a location where you think there may be a fault. You can pick these very easily by just making sure that nothing else is selected, and then you just go ahead and you come up here to Add Fault Points. Click that on, and you just click on a well, and that will create a generic fault pick, the user fault pick number 1. If you want to delete it, you just hit the delete key on your keyboard, and you go ahead and say OK, and it will be gone. Okay? All right. Now, before I pick a named fault, I want to make one more comment. There are two working modes in the smartSECTION cross-section. To access these modes, you just click anywhere where there's white space, you do a right mouse button, and you choose Draw Modes. You can also just click an F8 button. Now there's two modes. There's the True Space mode and the Straight Line mode. The Straight Line mode is just a simple cartoon-like mode that connects straight lines in between wells. This is kind of the traditional cross-section display that most of you are familiar with, and it's similar to how X-section works. However, since you've got the power of a 3D model here, we can also display what the true surface geometries are doing in between wells. So you're going to want to normally work in True Space mode. And as you can see, when I turn on my True Space mode, you can see all kinds of surfaces and changes in geometry between the wells. And these are all real. These are based on fault picks made by you, the geologist, outside of the plane of this section. All the data, again, that you do is encapsulated here in this particular line of section. All right, so now we're going to go ahead and pick a brand new fault, but first we're going to create its name. To create a brand new fault name, we go to the New Surface Fault or Interval Data tool. We toggle on the word fault, and we go ahead and we enter a fault name, like webinar fault. You can change the color of it. I'm just going to go ahead and leave it as purple. All right, just going to go ahead and zoom in a little bit on this cross-section. And in the webinar fault that I've just created appears in our list, and I can go over here to our Add Faults Point tool. Notice that it is selected, and when I click on it, you can verify the selection of the correct name by looking in this box here. Now, I'm just going to go ahead and pick on a fault, in between a fault, on a well, between a well, and I'm just going to terminate it down here close to this other fault. Immediately, this fault plane is actually, this fault does appear in our map view. I'm going to go ahead and turn off this structure so we can focus in on our fault. I'm down here, our webinar fault. I'm going to turn on that fault plane. I'm going to zoom in. This is kind of a big area. And we can immediately see the closely spaced contours associated with this simple fault. Now, often we have an idea of the overall orientation of the strike and dip of the fault in our region, and due to the knowledge of this overall structural trend, we can refine the details of our fault planes as we're picking them by using our interactive fault map in here in the FrameBuilder map view. I want to show you an example of what we can do here. I'm going to minimize my cross-section and open this up a little bit. And what we can do after we turn on the structure contour map of the fault plane, we can easily add data points to this. What we do is we come over to our fault name, we select it, we do a right mouse button, and we say Activate Surface. When we do that, we can come up to the Add Interwell Points, and we can actually add new interwell points and drag them and refine the look of this fault plane. Let's say, for example, I know that it should be trending to the north here. I can also grab existing points and move them. As soon as I move and better enhance our fault plane in map view, I can go back to my cross-section and notice that indeed the fault has changed. It's shot here across this large growth fault. Now, again, it's very powerful because you can have all this access to both the map and the cross-section at the same time. Let me just go ahead and set this up. Now, let's say, for example, that you know that this is an older fault that should be cut by this younger, larger growth fault coming through here. And what we do is we have this great tool called the Fault Networks tool. It's located up here. And we can just apply that tool and automatically give it information to know what fault should automatically truncate against another. So what we do is we need to go to the GeoSurface Model Properties tool and go to the Networks tab. This is where we actually tell the model what fault should terminate against the other. So we're going to take this smaller subsidiary webinar fault and we're going to drag it underneath the larger through-going and younger fault 06. I go ahead and I say OK, and then once I come out of here, I just turn on the Fault Networks tool. What it does is it truncates the fault automatically against this fault, and then we can actually go in here to our map and I can show you where the webinar fault actually intersects and should truncate against fault 06. I'm going to go ahead and make that a bright red. So this is the intersection of the larger growth fault with the smaller fault that I just created. So you can use these tools very easily. That was only 3 buttons. I set up the hierarchy. I went ahead and selected which fault was the subsidiary, and you can have this happen. All right. Now after we created our fault, the next thing is we want to establish what the vertical separation is associated with that fault. So I'm going to come in and zoom in onto that fault. Now I'd like to reiterate that in general you don't even need to worry about the vertical separation because it's going to go ahead and look at all the data in your area and it's going to do the best thing it can do at the time, and normally that's right if you have a lot of constraint in your area. But if you want to go ahead and enter your own vertical separation values, you just select the fault. Notice that it's selected up here. You do a right mouse button and you choose the first item on the menu, which is the Edit Current Selection box. Now this opens the Surface Data Editor box, and in here you can see the surface name, the surface type, the strike, dip, and dip azimuth of the fault plane, as well as other information. Now this was just a fake fault that I did create. Model knows enough to know there's probably no vertical separation here, but let's just say I want to override the model and put in 60 feet. I'm going to go ahead and save that, and what it's going to do is tell the model that the geologist thinks that there's 60 feet of vertical separation. What it will do is interpolate that value across the fault plane. Now, in order to get the model to accept that, I need to pop one more time back into the GeoSurface Model Properties tool. I go to the Faults tab and I click on this little toggle. Some of you may just want to keep this on all the time. It's called the Use Vertical Separation, and what that does is it uses the vertical separation given to the model by the geologist. At this point, I am now ready to go ahead and offset my faults automatically. I just come up and I click the Fault Offset tool. And what that's going to do, I'm going to zoom out here in a minute, is it's going to go ahead and it's going to offset these surfaces. I was having a little problems earlier with my computer, so I apologize for the delay. So here you go. Here's that automatic offset that's occurred along that fault. Now, one thing that's extremely handy is if you know that your fault is dying out, you can create an inner well point at some point, select it, and give it a vertical separation value of 0, and that will go ahead and die that fault out. Okay, so there's several different options you have here. Now finally, we've gapped it, we've inserted our vertical resolution, and we've offset it. And what we can now do is we can gap that fault if we wish. Now normally when I gap a fault, it's in order to try to finalize my correlations of my surfaces. So what I do is I go ahead and get more in a stratigraphic mode. I turn off my fault offsets, and sometimes I'll even go ahead and hang on a particular surface. To hang here, we just select a surface and we hit the space bar. Then I can go ahead and turn on my gapping tool. Now the gapping tool is an F4, or you can do a right mouse button, gapping, and click on fault. And what that does is it will automatically show me that 60 feet of missing section, and it gaps in between the wells. Just to kind of show you the effect this has on my giant fault here, you can see my giant fault has quite a bit of offset going on at this point. Now, what you're also going to see here is you can come in closer, and when you are in gap mode, now this is the fault cut position, so you don't want to be moving it unless you truly do want to move the fault cut position, but you grab this lower unit and you can click, you can drag and increase or decrease the amount of vertical separation on the fly. Most people use this, again, to help them reconstruct the original geometries. Okay. John, any questions coming in here?
Yeah, I actually have one quick question that one of our users asked, and I'm answering it. It has to do with truncating faults into unconformities, which is a brand new question that I've actually never had before. So I'm in the process of answering him, and we'll get back to on that one.
Do you want to answer it to everybody or not? You're going to do that maybe later at the end of the session.
Exactly. That's what I'm going to do.
All right. Okay. All right. I'm going to go ahead and zoom out here a bit. Okay. And I'm going to, now that we've seen what we can do, again, we're picking faults, we're gapping them, we're truncating them, we're offsetting them. I'm just going to go ahead and go back into structural mode by clicking my space bar and the control. Well, it's saying I have a fault selected. I've got to select something else, and now I can go ahead and get into structural mode. You can also come up here and do view structural. Okay, now coming back here. Now what I'd like to do is kind of show you what's going on in the map view. There's a lot of action going on here we haven't been focusing on. I want to show you the 4 different kinds of surfaces that can be turned on in map view and how we can manipulate those surfaces. First thing I'm going to do is just turn off our webinar fault and also the intersection of that webinar fault. And I'm going to start kind of with the simple stuff here. All right, and zoom out to our study area, our simplistic study area. All right. The first kinds of surfaces that we can show are any kind of structural contour on top of any of our surfaces going on in this area. And again, these are these surfaces. So in the map view, I can come over here, turn on my correlations. I've got my O2R KL1 unit here in blue, and I can instantly show that surface here. So that you can just march down through your section, show all the surfaces. Okay. Second of all is when we want to work with faults, we can turn on the fault plane all by itself. So this is the fault plane of the down to the south faults here. Let me go ahead and zoom out here so I can point to things. Okay. Now, you know, this is great and good, but this isn't what we're normally wanting to see in our maps. What we're really wanting to see is the intersection of our surface with the fault plane and get that classic fault polygon that we're used to seeing. So in order to do that, what you do is click the little plus sign to the left of the fault, and you will see all the intersections of that fault with each surface. So you turn the fault plane off, you turn on the structure contour map of your surface, and then you select where that fault intersects that particular surface. Now let me zoom out a little bit more here, full extent. So here is where that fault intersects our structural contour surface. Now we still aren't seeing the vertical separation and the offset yet because we haven't turned on the fault offset tool. Now I still have the fault networks tool on. I'm going to go ahead and turn that off, and I'm going to turn on the fault offset tool. When I do that, the contours are going to offset, and we're going to see a thickness of the polygon indicative of the vertical separation. Okay, so you can see how the vertical separation changes throughout our area. And then it's extremely easy to just pop into any of your surfaces. You need to make sure you've got the right thing selected here. So this is the fault for that surface, and we can go very deep in here, go to a much deeper surface that where maybe there's not enough as much information on. I can go ahead and pick that fault intersection. So basically what we've got is these your classic polygons that you'll see in a classic GeoAtlas fault. All right. Now, any questions, John?
So far, just the one question.
All right. I guess.
Beverly, you're basically mesmerizing the audience. What can I tell you?
What can I say? All right. So now comes the most interesting part to all of you guys out there who have your detailed structure maps in GeoAtlas that you've made based on seismic data and you're saying, well, great, the geologist has brought me all this information brought on well data. How do I integrate my seismic-based fault map with the data coming in from smartSECTION? Well, we've got that covered. Let me just go ahead and maybe choose a shallower map here with its intersection. And what I'd like to do is take this into GeoAtlas and incorporate the data from this map. Now remember, all the well pics are already there. It's just this new fault that hasn't, all the fault data has not arrived into the GeoAtlas world. So what we just do is we come up to the actual correlation surface, we do a right mouse button, and we choose Create ISOMAP Layer. It is this easy. So you come in here and you go ahead, and I'm going to just call this my webinar fault layer, what was it called? O2. It's right, it's actually right here, O2 RK. I'll just leave it simple, and I say Create ISOMAP Layer. You'll see the classic ISOMAP build surface dialog box. You can change things if you want, or you can just hit Finish, and then you go to GeoAtlas and you open up a new map, and it's right there, sitting there to be used, right there. I say OK, and that smartSECTION map appears in GeoAtlas. Now what's really nice is when that fault polygon comes over, you can just merely select the fault polygon. If I can get on it, zoom in a little more. And then I can do an edit, copy, and that all the information related to that fault, so all the elevation values associated with all the nodes along that fault are now can be just dropped and copied into your larger structure map based on other forms of data. And then you can just use the functions within ISOMAP itself to combine this information with your other information. All right? So it's very easy to get this all linked together, and very quick, might I add. Now finally, for those of you who say, oh, don't trust this smartSECTION thing, I want to see right now my GeoAtlas map, all you need to do is come up to Geo Atlas Layers, do a right mouse button, select Layers, and you can go ahead and turn on any map you want. Now I just happen to have a map here that I built in GeoAtlas on the O1QCO6 layer. I'm going to turn off my O2RK01. This is my GeoAtlas map showing with my smartSECTION map on top of it. Okay, here's my fault, and then I can also go and choose that same layer and compare it to the more detail that's coming in from smartSECTION. So you can see the overall trend is the same, and basically the differences is that we have a little more information coming in from smartSECTION. Okay. Now, I have some mic issues here. Can I ask my co-presenters, what time is it? Do I have enough time to show them the example of the reverse fault, John?
Yeah, Bev, we're about 40 minutes in.
Okay.
You're doing a great job.
Maybe we could address a question or something while I go out and switch projects here.
John, can you move forward? You've been sent a number of questions. Do you have them lined up? Hey, John, do you have your questions lined up? John, I think you need to unmute yourself.
Yeah.
Do you have your questions lined up that we can fill the gaps while Beverly's just switching over her project?
Well, one question someone just asked is, well, when Beverly copied that fault, where did it go? Well, what she did was you copy these entities like a fault polygon to the clipboard and then paste it on, for example, another ISOMAP layer. And I have some geologists out in California where everything, of course, is all faulted up. They will let smartSECTION, with their sophisticated smartSECTION FrameBuilder interpretation, they'll let smartSECTION create these fault polygons. create a layer like Beverly just did, and then copy one or more fault polygons, which again contain all the elevation information on each node on the fault polygon, copy them to the clipboard and paste them on an isomap layer that they may have been working for quite a while, has a lot of data associated with it, and maybe some hand edits of the contours, and then they will essentially regrid that isomap layer with the new fault polygons to get their final isomap. So it's a very powerful technique. So that's essentially what she was just showing you there.
Okay. Well, let me just briefly talk about this, John, and then that will give you time to regroup on the questions. This is just a small little project in Kansas. I don't even, actually John did this. I'm not even sure if it's a real fault or not a lot of thrust faults in Kansas. But here we've got an example of a reverse fault based on all the information that we've put into this system. And what's really nice about this particular example is it shows you how smartSECTION models, because if you look at the details of our contour map, is you can see how the contours come all the way to that fault surface in both the thrusted upward versus the underhanging fault area. So this particular contour map is over here. You can actually see these relationships, which is really nice. If you're drilling a well in this area, you'll know exactly what's going on and where you are. One thing I didn't do in the other cross-section, and I'm not as familiar with this project, but just remember, at any time you can come up to cross-section, define projected, click, right mouse button, end definition, and instantly see all the relationships of that fault. In this case, the fault's green. Let me just make that some other bold. I'm into red here. Red's up here. And thick. And you can see the relationship in a 3D view of that fault, how it's going through and intersecting the other units. This is, again, very powerful. You can just do this a million times. You can even grab this guy and move him anywhere you want, and almost like in a movie, watch that fault move and intersect the units. So this is just a very powerful, quick, interactive tool. John, do you want to discuss any more questions? You know what, John? I apologize. I have lost audio with you. I cannot hear you at all.
No, I was muted, Beverly, sorry.
Okay.
A user asked if it's possible to use seismic attributes to pick faults and build 3D models. Essentially what you can do at this point, and I'll give you a little hint for what might be coming in the future as well, gang, but what you can do is display a seismic backdrop in the smartSECTION, and that seismic backdrop can include horizons and faults that you've picked in Size Vision. And then, of course, what you can do is you can add points, primarily interwell points in most cases, in your smartSECTION cross-section and create your faults and or your surfaces, for that matter, adding if you don't have a lot of well control, within the smartSECTION model. And one of the techniques that people use, you can maybe, because you're looking at a 3D model within smartSECTION and FrameBuilder, you can create what we call arbitrary cross-sections anywhere in the model. You don't need to create well-to-well, and then move them along and through the seismic essentially, and continue to create interwell points. Okay, so that's a very powerful technique, and the hint I wanted to give you guys vis-a-vis the future is that we're considering taking horizons and faults from Size Vision and being able to essentially let smartSECTION ingest those into the model. So the XYZ data points for your seismic horizons and faults go right into the model.
Yeah,
very, very exciting potential future development.
Yeah, I thought maybe I'd have that project here, but I don't. But it really is a very powerful tool as well.
Are you referring to that geosteering project with the backdrop?
Yeah, I don't have.
Yeah, you got it right
seismic
there. You can actually show them.
But no, John,
yeah, if you fire, well, we may.
John, I don't
yeah,
have
we'd
the
have to
seismic
set it up,
loaded.
I think.
Yeah.
I see. Yeah, there's always a little tweak where you have to actually show it where the seismic is, and then it'll show up. So we can
Yeah,
set that up.
John, let's focus on, I think we've got a number of questions coming through now. Are you receiving them? Why don't we just take a few minutes to get through the questions first?
Let me take. Yeah, would you like to do that orally, Justine?
Yes, yeah. Why don't you just continue to do it orally, and let's address
see
the
what we have
questions.
here. Let me take a look at some of these. There's one here, how to link the fault polygon in GeoAtlas with the fault drawn in the cross-section. Well, the fault polygons in GeoAtlas, unfortunately, do not talk to smartSECTION. However, again, if smartSECTION has fault polygons that you've created or that smartSECTION's created on the fly, Beverly showed you a technique to get those into GeoAtlas, so it's kind of a one-way street in that regard. Let me take a look at some of these others. Someone said that is cool, so I just wanted to comment that yes, this is very cool. Let's see what else we have here.
I'm just trying to get the project up one more time here.
Beverly, Larry said, please discuss the nodes where horizons intersect faults.
I'd be happy to.
In other words, how to edit them. So you want to go ahead and take a look at that.
You bet. Thank you, Larry. I forgot to mention that. Those points are actually open circles, open hollow circles, and they're called bed offset points. And you can actually move those bed offsets and change the amount of offset on a fault. Give me a minute here to get everything up and running. All you do is literally select those points with your pointer tool and move them up and down along the fault. The only caveat on that is if you do that, once you move that point, it is going to say, oh, the geologist is overwriting everything I'm doing forevermore. So let me just go in and show you. So I'm going to go ahead and select that fault. These are the bed offset points. You can grab them and move them to be exactly where you want. But from now on, the model is actually going to say, you know what? She's moved it. She wants it there. I am not going to interfere with that. Now, I do know I had an enhancement to delete that, and maybe I did get that in this last version, and I did. So actually, you're not stuck anymore. You can actually delete the fact that you've moved the bed offset point now and go back to how the model does it. But those are called bed offset points, and they're the intersection of the surface with the fault plane. John?
We have a question from Ali. He asks, can you import time or depth surfaces from a 3D interpretation from another package, such as from another seismic package? And the answer is yes, actually. You can, vis-a-vis surfaces, you can get an XYZ export from another seismic interpretation package that can be brought into ISOMAP and gridded, and smartSECTION you can actually source, and yeah, there you go, Beverly's showing you, you can actually source a surface in smartSECTION either from Wellbase or from an ISOMAP grid. So yeah, what people actually do, and a lot of people, of course, that are drilling horizontal wells and maybe interpreting their seismic in another package, perish the thought, will go ahead and export XYZ data, get it into ISOMAP as an XYZ import, grid it, and then source a top from that grid and show it in the smartSECTION. And of course, using something like smartSECTION's conformance tool with that detailed surface coming off of seismic data. And you can also, of course, incorporate well-based data with the XYZ data, right? In ISOMAP, you can have multiple data sources that create your grid. And they'll go ahead and use that to constrain their other surfaces, such as the surfaces that might bound their target, their horizontal drilling target, if you will. So absolutely, that's a very popular technique for folks that might be using SMT or some other product.
And you can actually even constrain that ISOMAP, constrain other surfaces to that ISOMAP grid. We have what's called the conformance tool, where you can constrain any surface to another surface immediately, and that's especially nice in areas where you don't have a lot of control. The unconventional drilling folks use this all the time when I'm helping them with their horizontal wells. They have a targeted surface that they know is 40 feet below their, a specific seismic interval. They can actually put that into the model, and you can see that and geosteer your well right into that surface. So that's the topic of another webinar. John?
I am, let's see here, answering some questions privately, and let me go see if I've missed anything. Is more than one gridding option available for surfaces in smartSECTION? Not yet. Currently, we do triangulation because it's the fastest, and remember, these surfaces are created on the fly, but you can, of course, push these surfaces to ISOMAP and open them in GeoAtlas and use whatever gridding algorithm you like to your heart's content.
Yeah, remember, it's so easy. You just turn them on, do a right mouse button, create ISOMAP layer. You can take it in there. You can put beautiful headers, print it out. The printing out of here proper is not what you guys are used to. It's just a quick and dirty map. We can do some headers, but you just take this map into GeoAtlas and you can do everything you've ever been used to doing with it.
Question, to see the seismic backdrop, is it necessary that the seismic be in depth? No, it will. If you have a solid velocity model, and of course that's critical in any case, if you have time, you have a time volume, if you will, and a good velocity model, smartSECTION will do its thing with time data. You don't need depth data. Let's see what else we have here. How does GeoAtlas handle the reverse fault when imported? I'm not sure I completely understand that question, so David, if you wanted to maybe elaborate on that. Let's see what else we have.
Here's what I suggest, John. Beverly, why don't we go ahead and wrap up here while John just finishes up reading the rest of the questions, and then we'll just do a final review of questions at the end. I just want to make sure we get the wrap-up complete.
Sure. Well, in conclusion, I hope that I've shown you how you can use smartSECTION and FrameBuilder to pick faults, display faults, interpret faults both in the cross-section and map views, and integrate all that data into GeoAtlas. We've covered a lot today, and while I'm comfortable using the software, you still may not be so. So please know that everything I've said has been included in 2 white papers that are out there that I've written and put on the support portal. I like to just pitch here. This support portal is really great, folks. Get in there. There's over, I'd say, 50 white papers out there, 30 alone just in smartSECTION that you could go out and read. And also, this webinar has been taped so that everything I've said can be seen again at your convenience.